Good morning, friends. Now we are continuing the second part of that important questions and expected in the QR, the OR. So that now at a public telephone booth, arrivals are considered to be a poison with an average interval arrival time is 12 minutes. So interval arrival time they given as a 12 minutes, and length of phone call may be assumed to be distributed exponentially with an average of 4 minutes. Here the question is traffic intensity or utilization factor. The formula for the traffic intensity rho equal to what? Lambda by mu. So now first we are going to find the lambda here. Lambda is arrival rate is 1 by 12 and the service rate is mu equal to 1 by 4. So to find the rho equal 1 lambda by mu is equal to 1 by 12 divided by 1 by 4, which gives that answer is here 1 by 12 into 4 by 1 equal to 1 by 3. Therefore answer B is the right option to the given one. Now traffic intensity, this is a repeated question. They will ask the traffic intensity or utilization factor rho equal to lambda by mu. Do you remember this? The second one, the queuing theory. If the arrival occurs according to a Poisson distribution, the interval arrival time is, in this given one already Poisson is there, so interval arrival time must be in the form of exponential. So there is no Poisson, there is no binomial, there is no order other than this. So if your arrival time is Poisson, means interval arrival time is this should be in the form of what? Exponential. Therefore it may be in the form of mean with 1 by lambda. A manufacturer has to supply, this question from the EOQ, economic order quantity. Here a manufacturer has to supply his customer 600 units product per year. Do remember the unit must be very important, per year or per week or per month. You read the questions carefully. Here a manufacturer supplies 600 units what? Per year. Shortages are not allowed. You have to read the questions very carefully. Shortages allowed or not allowed, based on the formula will differ. And the shortage is not allowed, and also that cost amount rupees 0.6 per unit per year. Unit cost is 0.6 per year. And the setup cost per run is rupees 80. So they are asking what? Economic order, optimum order quantity is EOQ only. First you read the formula. What the given here? Here they given the what? Demand. What's the demand we need here? 600 units per year, and the given cost, what they given the cost? C1 equal to 0.6, and another one is what? Setup cost. So that here setup cost, holding cost, everything you can mention the same word 80. So that economic order quantity or optimum order quantity, the formula is square root of 2D C. Here what we have? CH or setup cost, everything you mentioned the same, CH by C1. For that square root of 2 into 600 into what is 80, that 80 divided by 0.6. So now here 0.6 it is cancelled, comes what? It cancel 1000 into 80, 80,000 into 16,000. The square root of what? 16,000, which gives the what? Answer is 400. Therefore that here the economic optimum order quantity is option D, 400 is the right answer. For an item with the shortage cost of each piece is rupees 1. The shortage cost given is rupees 1. Setup cost is rupees 25. Demand unit is what? 200 units per month. The question is they're asking what? C min. So now the formula of C min equal to square root of 2 into D C1 into, they given the cost is what? Shortage cost. Okay, right. C into what? CS. Therefore that if we're going to substitute in this, square root of 2 into, what is the demand we have? Demand is what? Demand indicates what? 200. 200. The cost of the unit is, cost of the unit will come 1, and the setup cost is what? 25. For that 2 into 400, 400 into 25 become root of 10,000. then square root of 10,000 comes 100. Therefore that the C min, the minimum cost of the year which comes is 100. Now the next one, continuation. Customers arrive at a ticket counter at a rate of 12 per hour. This is given as what? Arrival rate. There is one clerk servicing in the customer. So here service is what? Single server. So here the question carefully, it's a single server or multi-server. That's very important. Here that the customer's arrival rate is what? 12, and there is a one clerk, means that is single server problem, and servicing rate is 30 per hour. The probability that there is no customer waiting to be served. Customer waiting to be served means is nothing but the ideal time of the customer. So now here lambda is what? 12, the arrival. Mu they given is what? 30. Now first you are going to find the traffic intensity, how busy the customers and the clerk is busy. Now here lambda by mu. Therefore that here the lambda by mu 12 by 30, which gives 0.4. Here you need the what? There is no customer. So that system is ideal. The meaning is system ideal. System ideal. So 1 means total value of probability you know is 1. That maximum value is what? 1. 1 minus how busy the system is what? Rho. So that 1 minus 0.4 gives us 0.6. So that system ideal. There is no customer waiting to be served. So no customer means clerk will be what? Ideal, without doing any service. So service is 0.6. The next. So now I am seeing more questions on the queuing theory, means yesterday we had seen more questions from the game theory and the TP. That's the reason the part 2 we are discussing more from the queuing theory part. So that here in a shop there is only one salesman at a counter. One salesman at a counter. One salesman, which is also indicate for single server. One server, one clerk, one salesman. These questions are indicates one server, single server problem. 9 customer arrive on average of every 5 minutes. 9 customers arrives every 5 minutes, while salesman can serve 10 customer in every 5 minutes. So average number of customer in the system. Average number of customer in the system. First you write that arrival rate. 9 customer in what? 5 minutes. And a service mu. 10 customer in what? 5 minutes. So that here 9 by 5 is nothing but 1.8. 10 by 5 is what? 2. Now our aim is to find is average number of customer in the system. Customer in the system, LS. That is called LS. Lambda by mu minus lambda. Lambda value is what? 1.8. Mu is 2. 2 minus 1.8. 1.8 divided by 0.2. The answer is 9. Therefore, the average number of customer in the system is 9. The system has 100 units in series, each having a reliability of 0.98. The reliability of the system is the reliability of the system. Yeah, the reliability of each having a reliability was 0.98. You have 100 units. Therefore, that here that reliability of your system. Reliability of your system is, here you have that what? Reliability is 0.8. 0.98 into 0.98. Like that you are going to use what? 100 units for what? 100 units. Therefore, the result is 0.98 the power of 100. So read the question quickly. The system has 100 units in series, each having a reliability of 0.98. The reliability of system is, so each one is having a 0.98. You are using 100 units. Therefore 0.98 into 0.98 into 0.98, you are going to multiply with what? 100 units. Therefore that 0.98 to the power of 100. Therefore answer A is the option A is the right answer to the given one. Now next is mg1. So that here m which indicates Markovian, g indicates general. Actually that first two which comes always the Markovian model only. So I'll read the questions fully first. m/g/1 queuing system involves. Here what type, the question is what type it is. Multi-server, Poisson arrival, general service, time distribution, or single server, Poisson arrival, general service, time distribution, no server, and single server, binomial arrival, general service. See that always the first one indicates arrival part, the second one is service, first one is always arrival, second one is arrival, service, the third one is indicates always the what, server part. Here server is what, single server, this is indicates single server. Here single, there is no multi server, this is not a multi server, this A is not what, wrong, no server. Now it server is there, so no server is also. Single server, binomial arrival, we never use anywhere the binomial, we can use mostly the Poisson arrival, therefore this is also wrong answer. Therefore it is the answer is single server. Yes, binomial arrival must be always binomial. General, g indicate what, general service, therefore option B is a right answer. Single server, Poisson arrival, general service, time distribution. So option B is the right answer to the given problem. m/g/1, this one which indicates single server problem. In an economic order quantity EOQ problem with no shortages, then the lead time is always no shortages. There is no shortages, always what we have, the enough quantity we have, there is no shortages. Therefore the lead time will be always 0. If no shortages means the lead time must be always 0. The principal actors of queuing models. Queuing models always depends on the two things. One is the customers and one is the servers only. Do remember that too. Here the question is the principal actors of queuing models are customers. They are asking the option A is the customers, option B is the servers, option C is the customers and the servers, and what? None of this. So here you must remember one important thing in the queuing models. Queuing models mainly depends on the two things. One is the customers, I mean the arrival, and the based on the server, how server is doing the service, how fast it is doing that. So that queuing theory mainly depends on the models of customers and the servers. Option C is the right answer to this one. The main decision in inventory controls are, so the main decision is based on the what factor? They given the options: size of the order placed, the time of placing the order, the size and the time. These two are important. These two factors are very important in inventory. So how size and how frequently are ordering this. So that here the main decision of inventory controls is it depends on the two factors, is the size and the time of placing the order. Therefore that option C is the right answer for the inventory control main decision. And the continuation of this here, the expected waiting time in the system is 10 minutes. The given the waiting time in the system, do remember what they given first. Waiting time in the system is 10 minutes. Expected waiting time in the queue is 5 minutes. Expected waiting time WQ and WS they given. That question is then the service rate. Then the service rate means they are asking the what? The question is they are asking what is mu? Mu is what? That is question. So the given thing is what? Waiting time in the system WS is what? 10 minutes. And waiting time in the queue WQ is what? 5 minutes. The question is what? Mu. So that you are going to use that simple formula here. WS equal to WQ plus 1 by mu. Here WS value is what? 10 equal to 5 plus 1 minus mu. This implies here 10 minus 5 become what? 5. 5 equal to 1 minus mu. This implies mu equal to 1 by 5. So therefore that service rate is 1 by 5. if it is waiting time in the system and waiting time in the queue is given. So by using this relation, Ws equal to Wq plus 1 by mu. So using this only you can find that the what? Service rate of the system. Now, traffic intensity. I told you very clearly when I started the queuing theory, the traffic intensity of this model, MM1, which indicates arrival, service, and the what? Server. That what? Server. Single server. Arrival and service both are comes in the model of MM, which indicates Markovian models. What is Markovian model, sir? Here that future is depends on the present, not on the past. So you can calculate that the future only the existing data, not on the past data. That depends on that one Markovian process. M with the single server system is given by, you are going to find the traffic intensity. Traffic intensity always a rho equal to lambda by mu. This is the what? Traffic intensity formula. This is a very important one. Most of the problem we are going to discuss based on this traffic intensity only. Inter-arrival time is 10 minutes. The arrival time rate is, so now inter-arrival time, that 1 by lambda is given is what? 10 minutes. So the question is arrival rate, that implies arrival rate lambda equal to 1 by 10. So that next one, the relationship between the expected number of customer LS and the expected number of customer in the queue LQ. LS, LQ, also the given arrival rate of the customer in the system lambda, and the service rate of the customers in the system is mu. They given the four things: LS, LQ, mu, lambda. That relationship, what way these four are related? None of this is a what? LS plus, no, this is not. LS divided, no. So LS minus LQ equal to lambda by mu. This is the right answer. These four are related like this only. LS minus LQ equal to lambda by mu. Now the next one, that everyone mostly give more important to this model. This is a what? First model, M with a single server, no multi-server. We are discussing most of the problems will come only in the part of the what? Single server, and then only you can think about the multi-server. Here most of the questions are repeatedly they are asking from the single server only. Give more important to the single server questions. For Markovian arrival, server is also Markovian, the single server queuing system. In the system, expected number of customers in the system, or LS equal to rho by 1 minus rho. This is the right answer. This is the right option to that given one. LS equal to rho by 1 minus rho. Rho is what? Traffic intensity. First you are going to find the traffic intensity. Traffic intensity divided by 1 minus the traffic intensity is give to what? LS. Traffic intensity, rho, which indicates traffic intensity by 1 minus the traffic intensity, which gives that what? LS, length of the system or customers in the system. Next one, for MM1 first model, single server queuing system, if arrival rate is 10 customers per day, and the service rate is 30 customers per day. The expected number of customers in the queue in a certain day is what? Expected number of customers in the what? Queue. So that the given one is lambda. Arrival rate is what? 10, and the mu also they given 30. So now our aim is to find first the traffic intensity. What is the traffic intensity? Equal to lambda by mu. The 10 by 30 equal to 1 by 3. Therefore, the traffic intensity 1 by q. Our aim is to find that q, length of the q, LQ. LQ equal to rho square 1 minus rho. Therefore, that 1 by 3 the whole square divided by 1 minus 1 by 3, 1 by 9 divided by 3 minus 1, 2. Therefore, that 2 by 3, 1 by 9, 2, 3 by 2. So 1 by 6. Therefore that LQ 1 by 3, 1 by 6. 1 by 6 the right answer to this given problem. That everything I am discussing mainly focusing on the single server problems. So single server problems only mostly they are asking, repeatedly they are asking. So give more important to the single server problems. The next one. Arrival rate is 3 customers per day. 3 customer arrival lambda. And the service rate is 5 customers per day mu. Then for using a what? Single server, I am always concentrating the single server. The repeated questions for the single server, Markovian model of both arrival and server service, and the single server queuing system. Expected number of customers in the system a certain day. Expected number of system a certain day, LS. So that I told you very clearly, if it is given, you are going to find always a traffic intensity. Traffic intensity very important. Traffic intensity, find the traffic intensity, we need the lambda. Lambda the given is what? 3. Lambda is 3, mu is 5. Therefore traffic intensity lambda by mu is 3 by 5. So here expected number of customers in the system, that is LS. LS equal to rho by 1 minus rho. So that 3 by 5 divided by 1 minus 3 by 5 equal to 3 by 5 divided by, here 5 goes that 2 by 5. Therefore 3 by 5 into 2 by 5, 5 by 2. 3 by 2, 1.5. 1.5. Therefore option A is a right answer for the given one. Next, n equal to 10. N, capital N, remember that. Arrival rate is 2. N is 10, arrival rate is 2. Then see here I am talking about most of the repeated problem I taken from that old question paper only. MMN model system, the expected waiting time in the system for rho equal to 1. Traffic interest to what? 1. Now that the question they are asking is what? Waiting time in the system. If they given only what? Lambda is given. That waiting time in the system, WS equal to, by using capital N, N by 2 lambda. N by 2 lambda. Here lambda is given. Lambda is what? 2. Therefore that N is 10. 10 by 4. 5 by 2. So WS is 5 by 2. So why I am using this one? If they given the two data like this, capital N and the lambda, means to find that WS by using the relation WS equal to N by 2 lambda. By using this one you can find the what? Waiting time in the system. Let N, capital N is 15. Then for O equal to 1, traffic intensity, Pn, probability of n customers in the system of MMN, Markovian model of that single server with finite number of customers. That queuing system is the probability Pn they are asking. So therefore that formula of that Pn equal to 1 by n plus 1. So that what is the capital N they given? Capital equal to what? 15. The N they given the problem is 15. Therefore that equal to 1 by 15 plus 1. That 1 by 16. So this is the answer for this. So for this given question, option B is the right answer. Pn equal to 1 by 16. So thank you friends. Shortly we will meet on that next video and other chapters important questions. Thank you. Thanks for your support. I request you to kindly extend your support and subscribe the channel.